All right, so I'm not even gonna really talk about this one. This is just gonna be, if you wanna know what the value of the function is when you're out at 10, I mean, either find the slope or just extrapolate the line, right? That's no big deal. You got that. So, okay, something like this. There's gonna be a couple questions on here maybe about a few things we haven't done yet. Like this is the exponential stuff. We're gonna do this before the end of the year, but we haven't done it yet. But this question you can answer. They want to know, this graph represents the equation of this function. You know, it could be any function, but in this case it's an exponential function. How many ordered pairs for x is greater than -1 and less than 2 satisfy the equation? Well, how many points would there be on the function between -1 and 2? Infinite number, right? It's a continuous function. And so you remember we talked about thinking of a line, for example, as a collection of just an infinite number of little beads on a wire. Right? There's no limit to the number that there are. Okay, so that's the idea there. How many solutions are there to that system of two linear equations? One, because they cross in one place. What's the solution of the equation? Well, just where they cross, right? I mean, that's, for you guys, that's no big deal. Okay, what about this one? Let's take just a second on this one. So the graph of y equals p to the x is shown. P is a quadratic function. Select one or more intervals with consecutive integer endpoints that contain the solutions of the equation 9 equals p to the x. So we're just setting y equal to 9, right? If we set y equal to 9, you can see that the intersections are right there.
That's 7.
Oh, you're right, that is 7. Let's see, what's 9 come after again? 8?
Yes.
Okay, so right there or right there. And so this one is going to be pinched between that integer and that integer. So we're just going to shade there and there, right? Between -2, and I guess we shade it down here, but between -2 and -3 and 4 and 5. No big deal, right? I mean, you just have to read these carefully, but they're not hard at all. Same kind of thing here. You're interpreting the system of these two graphs. So, I mean, if this is g of x, g of 0 is going to be greater than f of 0, right? So that's false. G of 0 this says g of 0 is less than f of 0. False, right? 3 is the approximate solution to where they intersect. Yeah, that's right. There's 3. That's the x value of that coordinate, etc. I mean, it's no big deal. You just read those carefully and interpret the graph. Okay, real quick, this stuff. So remember here that the set of ordered pairs that are solutions to an inequality, all you're going to do, they want us to try to find the inequality that represents the graph. Okay, so remember how this works. It's just going to be the equation of the boundary line, and then the inequality sign is going to shade one side or the other, right? Remember, there's two ways we can think about this. If the equation is in slope-intercept form, if it's set equal to y, then it's really easy, because then you know that if it's less than, y is less than mx plus b, it's always shading below the line. Like if you took any point on the line and drew an arrow straight down, it's pointing into the solution set, right? And if it's greater than, it's pointing up into the solution set. And remember that if this is less than or greater than, it's a dashed line because it's just a boundary, it's not including the line. If it includes an equal sign, it's a solid line. Remember all that stuff. You can also, well, in the case of something like this, how about? Okay, so graph the lines representing the boundaries of the system of linear inequalities. And then they want you to plot a point within the solution set. Okay, so if the lines are negative 4x plus y is greater than 0. How do you plot that? Right, we've got two options. Just really quick review of this. I won't spend a lot of time on it.
You could put it into y-intercept.
Okay, you could really easily put that into slope-intercept form, right? And then just graph it that way, and that's fine. And that's sort of convenient because then you have y is greater than mx plus b, and so you know that for that one, you're gonna shade above it, right? Okay, the other thing you could do, let's look at this bottom one. This is just, I'll remind you of a little trick here. And you can always do it the other way. You can always just isolate y, and that's fine. But you can also do this. You could say, okay, we just need 2 points, right? So what if we set x equal to 0 to find the y-intercept? What would the y-intercept be if I set x equal to 0? For the bottom one. Negative 2 times what is 6? Negative 3. Okay, so then you're going to get one point is going to be right there, right? Does that make sense? And then you could set y equal to 0 and solve for x. So x would be 6. So there's the other point right there. And then you just connect and extend to create the boundary line, right? This one isn't solved for y, okay? But if it were solved for y, what direction would the inequality sign face? I'd have to divide by negative 2, so it's going to flip it. So do you see that we're going to be shading below? The other thing you could do is you could just pick a test point and see if it satisfies on one side of the line. What if I pick the test point like it's 0, 0? If I let x and y equal 0, I'd get 0 is greater than 6, which is false, right? So that would mean that that blue point is on the wrong side of that line. I have to shade the other way. Yeah, that's fine. Does that make sense? It's just ringing a bell. And then when you're graphing a solution, you just want, if there's 2 equations, you have to find the part that's shaded by both of them, right? I mean, so that's probably all I need to say about that. Okay, these kinds of things, you know, this is no big deal. You just got to read the question, right? Because it's giving you, read it twice. So you know that you've got this height function where h is height in meters and t is time in seconds. We're telling you that that this model makes sense when t is greater than or equal to 0 and less than or equal to 12. So that's the domain of the function, and here's the range. Maximum height is 180, it looks like, right? So choose all of the statements below that are true. H of 5 equals 175. Well, how would we check that?
Plug 5 over t.
Plug 5 in, yeah, and it turns out it's true. The height of the rocket is 0 meters after 12 seconds from launch. So if I put in 12, yeah, I'm going to get 0, all right? Plug it in. Okay. H of 0 equals 40. False. H of 0 equals 0, doesn't it? Right? The rocket reaches a height of 360 feet. No, it doesn't. Its max, its domain is only up to 180, right? So clearly it can't get up to 360, right? Okay, domains where functions are defined. We've talked about this enough that I think you guys are fine with this. What are the rules we have to follow? I mean, there's really only 2 for real numbers. You can't what? Can't divide by 0 or
Take a square root of a negative.
Take a square root of a negative or an even root of a negative. That's it. Those are the only things you have to worry about, right? So here, what's the one value that we couldn't have? 6. Yeah, so there it is, right? X cannot equal 6. That's the domain. How about here? Well, now everything under the radical has to be non-negative, right? So what could we do? We could just say everything inside the radical, which is a 6 minus x, has to be greater than or equal to 0 and solve. Subtract 6, divide by negative 1, and it flips the inequality, and I just get that, right? So, that guy right there. See what I'm saying? This one would be fine, wouldn't it? Nothing on the bottom, no square roots. Same kind of thing here. Just set x plus 6 greater than or equal to 0. Solve, so x is greater than or equal to negative 6. No big deal. Okay, what about this? For what values is the given function undefined? Wherever the denominator is 0, right? Does that make sense? So I would just set x squared minus 4 equal to 0 and solve, and those would be the 2 values where it's undefined, because it has 0 on the bottom, right? Nothing, you know, just got to think about it a little bit. Take your time. But we can probably skip that. I kind of want to move on a little bit. Okay, so let's just briefly take a look at these. The equation of any line can be written in the form ax plus by equals c. Okay, we know that. A, b, and c are all real numbers. Choose all of the equations below that define y as a function of x. Okay, so you just gotta kind of remember, what is the definition of a function? There's two ways you can kind of think about it. Graphically, it has to pass what test? Vertical line test. Okay, and what is the fundamental definition? For every value of x,
One value of y.
there's one value of y. For every input, there's exactly one output, right? So so this one would make sense, wouldn't it? Right? For any value of x that I choose, y is going to be equal to 4, right? There's only one value of y. Check. This one obviously makes sense, right? And graphically, this is a horizontal line. That's fine. This is a slanted line. This would be a slanted line. Now what about this one? That term goes away and I end up getting negative 3x equals 10, right? So x equals negative 10/3, right? What's y? Is there any restriction on y? Y could be anything, right? So for that x value, how many y values are there? More than one, right? Infinite. So that's not a function. And makes sense graphically. What is that? What kind of line is that? If I graph it. Yeah, it's going to be a vertical line. So it fails the vertical line test, right? Because it is a vertical line, okay? Okay, so same kind of thing here. So this one might be a function because for every x value, there's only one y value, right? Yeah, go ahead. This one cannot be. How come?
There's 7 guys.
Yes, an x value of 7 produces 2 y values, right? So it failed the function test. And then this obviously, which graphs represent y as a function of x? Well, graph B does, right? The other two fail the vertical line test. No big deal, okay? Okay, interpreting these graphs. You guys will be great at this, but you just got to be careful. Take your time. So this tells us the number of music downloads as a function of time. Okay. The greatest amount of downloads was 180. True or false? False. That's a lot more than 180, isn't it? Right. Around day 42 is when the least amount of music was downloaded. Yeah, let's see. Is that right? So we're going by 1, 2. So if there's 5 between those go by tens, don't they? Yeah. So there's 40. Yeah, I mean that seems reasonable, doesn't it? There are 3 intervals where music downloads decreased. Let's see, 1, 2. I see. So that's false. The amount of downloads increased between days 30 and 50. No, it didn't. Right? So that's false also. Okay, makes sense? I mean, you're just interpreting a graph. You can do this. Think about this in terms, so this is going to be your x variable and that's your y variable. Think about it in terms of a graph. That's all I'd say, right? Think about where each of these points would be on a graph and answer the questions.
Have you figured out what the passing?
I don't think that there is like an upfront passing score. I think it might change every year.
Then what's a good score?
What you guys will get. You'll get a good. No, you will.
You're really not helping.
You'll do
I don't
fine.
think you
Really,
understand that we won't.
No, you will. You will. You
This is
will.
pretty easy so far.
How many questions are on the
Gonna
test?
do bye.
I want to say maybe I think it's 40.
40?
40, I think. Yeah. No, you'll do great.
Are they like,
We have a part
Like
that's like
this
trying to,
exactly,
like, how
or-
long will it take too? Because I'm gonna miss part of
It's,
it and then I make
well,
it.
I want to ask a couple questions. I'm gonna do a little research this weekend so I can give you guys some more specific instructions on Monday, but I think you can take as much time as you want, which you should. You don't understand, you don't have to get all right on this test. Right?
Yeah.
Well,
We know
I mean, you don't have to get, I mean, really, you're gonna do, you don't understand, trust me. You're not in my other classes. You're gonna do
understand
I'm
this.
gonna be behind already, and I don't wanna have to make the test up, because I'm already gonna be behind for
Yeah.
school.
Same.
So that's another thing, too. It's
Oh,
like,
don't worry about the school part.
Oh, well, we're worrying about the school
Don't
part.
worry about the school
So
part.
we're all kinda guaranteed an A on this, is what you're saying?
He said if we're gonna do great, like by default,
We're
we'll
gonna-
get the.
I'll make, if
2
you,
weeks?
If there's not
I'll
a
compensate you for the missed
Gotta
time.
make this right.
score, we're not.
The question's gonna be
We're
like
gonna
exact.
pass anyways. So that means that we will get an A on the
You're
test.
all gonna pass.
Is this like the exact type of questions on the test?
Yeah, I mean, these are probably a little harder. Honestly, these are weighted towards the more difficult end of them.
Oh, really?
These were written by, this is the other company that I kind of work with. These
So
are,
what
yeah,
about the
these are
Oaks
harder
test yesterday?
questions. What's that?
What about the Oaks test yesterday? Or whenever that was? Were those simpler?
Were those like harder or?
Those were probably easier than these, okay? Yeah, those are more similar to what they'll be like.
Okay.
Those are actually from SBAC.
Okay.
Right. So I mean, the idea here is these are, okay, these, I contributed to some of these are questions that stimulate the kinds of discussions, make you think in the ways that are gonna best prepare you for the test. But they're harder questions than you'll see on the test.
So if you're so confident that we're gonna pass this test, can we get our A grade now?
I mean, I know you will.
Can we have like a
Seriously.
cookie party too?
Oh, what?
You should buy
Party?
us all. You should
Sure.
buy us cake.
Sure.
Ice cream
Okay.
cake.
Yeah.
And a puppy.
And a puppy too? Okay, you got it. We'll have a class puppy.
Okay.
You guys will have to take turns caring for the puppy. So we'll have a rotating schedule. You gotta sleep here and care for the puppy. All right?
We need a puppy.
No poop on the floor, please. Okay, so let's keep plowing through these things here. Do we need to look at this one?
No.
No, you're fine. These are, I mean, I kind of want to just cruise through these. These are so. Okay, here, how about number 5? Real quick, number 5. So a model rocket is on the ground. It launches into the air at s=0. Assume the height of the rocket can be modeled as a quadratic function. Okay, it's a little, I need a little quieter, please. If it's a quadratic function, then we know that it's going to, it reaches a maximum height of 100 feet and lands 8 seconds later. So how could we fill in the blanks? So all we've got to do is we know that a parabola is symmetrical about its axis, right? So this is really simple then. If we know that it starts here and it lands, it reaches a maximum height and then lands 8 seconds later, then I know that if it lands 8 seconds after reaching the maximum height, it must have taken off 8 seconds before, right? So that also tells us that the point in the middle is at 8, the point 8/100, right? Well then I mean, you see the symmetry, how you just, those 3 points have to be where they are? That's all it wants you to do. Okay, this is no big deal. This is just one where you're going to graph a piecewise function. So there's just gonna be 3 segments to this. Each of them has a different slope, right? No big deal. I'm not even gonna go through it. You're fine. Okay. Tessa babysits for X hours at $5 an hour. Which graph fits that the best? The one that has a slope of 5 and starts at the origin, because obviously you can't, right, you can't go backwards in time, right? So, what's that? There's a lot of them like that. Yeah.
You better not be Josh enough.
No, I'm not. You have to remember, this test is for you. You trust me. You're not in my other classes. This test is for every high school student in America. You guys are the honors students.
But half the time I don't even get what we're doing in this class.
Oh, you're fine. Your grades are good. You must know what you're doing a little bit. Okay. Okay, so this is pretty simple. This is just, once again, interpreting a table. Alex records the number of minutes it takes to draw a picture in a table. So this is the number of pictures, and this is the number of minutes it takes, right? So choose the average amount of time it takes Alex to draw the first 3 pictures. So for 3 pictures, it takes him 85 minutes, so 85 divided by 3 is 20, well, it's not exactly, it's 27 point,
So it's just like the
27 and 2/3. So it's just, they're just gonna round it. They want you to round it to the nearest minute per picture. So you're just averaging, yeah. Right? So when he draws 3, it takes him 85.
What about 2?
Well, 2, it takes him 58. It's different. But they're saying
I know, but, the average time it takes.
to draw a picture when he draws 3, yeah.
So is that in the third? That's a confusing question.
It is a little
The times
confusing.
So we don't find the average of it. Cause the
You're-
average is different.
You're right, you're just saying for this one right here, when he drew 3, it took that long. So it took, now look what the answers are. It took 28 minutes per picture then, when he drew 3.
But couldn't it be the 1 plus the 2 also? That doesn't make any sense.
No, because for some reason, when he drew 3, he was a little more efficient. He drew it a little bit faster when he drew 3 at a time.
Well, that's just a confusing.
Yeah, it's not a very good question. I wouldn't swear.
Yeah, but the adding part's already done.
See, this is already telling you, it's a pretty bad question. I thought so too when I read it. I don't think it's really unlikely to see one.
That's not really
Yeah,
like that.
that makes more sense.
That confuses me.
It is a little confusing. Yeah, it is a little confusing.
Wait, I don't understand.
So
It's-
it's not like you don't do the average part, it's already added up by.
Yeah,
50. It's like
this
the full
is
amount
how
of
long
time
it
it's
took to draw 6 pictures. When he drew 6 in a row, this is when he drew 3 in a row, that's when he drew 2 in a row. So, choose the average amount of time it takes Alex to draw the first 3 pictures. Well, it took him 85 minutes to draw 3 pictures, so that works out to be 28 minutes per picture. 85 over 3.
Take out the first.
Yeah.
And just put three pictures.
Yeah.
I see it now.
Yeah, I don't think it's a very good question. I wouldn't worry about it.
Mine now too.
Okay, so here's one. The average rate of change for the height of the tide measured as feet per hour between 4 and 8 hours. So all we would do is go from there over to there, right? So you're measuring the slope of that line, which would be difficult to do. But there's going to be a range of values you could accept. So what's that going to be? That's going from like, what's that going to be? That's going from like,
0.5.
that's 10, so that's going to be about 9-ish, right? I mean, a little bit less than 9, so let's just say that's like 8.8 or something, right? And then this is going to be right here, that one's going to be a little less than 10, so that's like, I don't know, 9.9, something like that, okay.
So all
And
of
then
them are-
it's divided by 4, right? And so that's gonna be like 1.1 over 4, which is what? That's gonna be 0.2 something, right? But any value between 0.2 and 0.3 would be fine. So you're gonna get it, you know? That's all you're doing, though, is just finding a slope, yep.
So not all of them have multiple choice, some of them you have to fill in yourself.
There are some you fill in yourself, yeah.
Wait, does it tell you it says from 0?
No, you'll just put in the answer, but when it's graded, they'll just accept.
Oh.
You know, they'll accept your answer.
So what about
yeah.
the questions where it was like, explain your work?
Those, okay, Monday we'll go through that. Yeah, that's the performance stats part. Okay. Consider the function f of x equals 25x plus 60. Identify an appropriate domain for the following situations. Well, okay, this is just one where it's either going to be a discrete set or it's going to be continuous, right? So in this case, garbage truck has 60 pounds of garbage and each added bag weighs 25 pounds. So it's going in increments of 25, right? So then what's the domain going to be? It's going to be some subset of the integers, right? So it's only going to be integer values in the domain, right? Every 25. Does that make sense? Total money collected, if people give $25 each and one person gives 60. Once again, you're not going to have parts of $1. They're all just in bills, right? In increments of $1. So that would be integers. Total weight of a wheelbarrow, if it's being filled with sand at a rate of 25 pounds per minute. So the sand is just trickling into the wheelbarrow. So in that case, it would be all real numbers, right? I mean, I guess technically it's whatever the weight of an individual grain of sand is, but we'll just treat it like it's, right? like it's just continuous, okay? Okay, no big deal, you can do that, nothing to worry about. Okay, we did these, this is no big deal, right? This is just quick review. The parent function, what's A, H, and K here?
2 is A.
2 is A,
4 is H, 3 is
negative 3 is K, right, and then it's just the parent function is just f of x equals the absolute value of x, and remember, all that is a v, right?
4 is
Okay, that makes sense, so that's all you're doing. So then instead of going over 1 and up 1, you're going over 1, and up 2, right? Because you're going from negative, is that right? See, what,
Yes.
how is this going, by 2's? Yeah, so you go over 2 and up 4, right? Does that make sense? And then the coordinates and the vertex are just 4, 4, negative 3.
And we'll probably be able to plug that in on this one.
I don't know. You may or may not, but you don't need to. I wouldn't be surprised if you weren't able to on something like that, because then you can just graph it, but you can do that. I mean, that's just, the way we approach this, we always dealt with it in terms of a parent function and values of A, H, and K, so you can transform any function pretty easily, right? Just by stretching. If A is negative, it would just reflect it vertically, right? Okay. You guys are good at that stuff. We've had a lot of practice. Okay. Place a point on the max. Okay, so what about this one then? So how can we do this? Well, if we just need to find those 3 places, finding the x-intercepts is easy, right? I'm just going to set y equal to 0 and solve, right? So we're just, with the x-axis is where y equals 0, so we would just get the equation. So there's the equation we're going to solve, right? Solve the quadratic equation. And if we do that, evidently we're going to get the answers negative 3 and 1, right? So then at what x value is the vertex going to be? It's got to be in the middle, right? Because it's symmetrical. So we just evaluate the function at negative 1 to find out where the vertex is, right? No big deal. If you want to, you could put, I mean, it's too much work, but if you want to, you could put it into the general form where we complete the square, but you don't need to do that, right? I mean, just do this instead, right? Just think about the symmetry of a parabola, find where the x-intercepts are. You know where the axis of the symmetry is going to be, so just plug in that value into the function to find the y value of the vertex, okay? And you could make a t-table or something if you want to kind of just make sure it all makes sense. Okay, so this is one. So this is one where I'll just tell you how you can do this, because they don't do very high level exponential function questions on here. It's going to be growth if you're taking the function to, if you're taking a base that's greater than 1 to a power, it's going to get bigger. If the base is less than 1, it's going to get smaller. Does that make sense? Okay.
That's all there is to it.
Yeah.
Wait, which one's the base again?
So that's the number that's being taken to the power. So think about like 1/2, for example. If I take 1/2 to the 1 is 1/2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. So it's getting smaller, right?
Oh, gotcha.
See what I'm saying? Whereas if the number's bigger than 1, you take it to a higher power, it gets bigger and bigger, so it grows. That's all I gotta remember on those. And actually, that'll be enough probably to answer all those questions on the test. We'll do a lot more with it later in the year. Okay, we know these, just isolate. Oh, actually, hang on, no, never mind. So this is just one where, this is easy for us, right? This is one where we're just going to, well, we can do this a couple ways. We know what the graph of that looks like, right? Because it's A is 1, H is -9, K is -2, and it's just a square root function, right? So it has a starting point and just goes up, right? If we want to show where the x-intercept is, though, all we'd have to do is set that thing equal to 0 and solve. No big deal, right? And so we'd get -5 if we do that. Plot a point on the show where the y-intercept is. Well, the y-intercept is just where x is 0, right? So set x equal to 0 and evaluate, right? So I'm going to get square root of 9 is 3 minus 2 is 1. Okay, all right. So I would just, on this one, I would just graph both of these and then just like on the same xy plane on graph paper, and then just see where they're both decreasing. You know, where the parabola is going down and the v is going down at the same time, right? It's going to be a small interval where that happens. Line of symmetry. Okay, so this is an easy one, right? This is all we got to do here. We know where are the coordinates of the vertex of this parabola.
6 and -5.
6 and -5. So if the x-coordinate of the vertex is at 6, what's the line of symmetry going to be? X equals 6, right? It's going to be a vertical line through the vertex. That's the folding symmetry of the parabola. Okay, and then how do we do it here? Well, a couple ways you could do it. You could complete the square, but the easiest way to do it would probably just be to do, what would you do?
Quadrant.
Okay, yeah, because you could set it equal to 0 to find the x-intercepts, right? And then it'd be the average of the two. It'd be halfway in between would be where the vertex is, right? Okay, that's a good strategy. I like that. All right. How about this? So graph shows f of x. Table shows some values of another quadratic function g of x. The line of symmetry of f of x is x equals 5. That's false, right? False. It should be 3. The value of x when f of x is at its maximum is greater than the value of x when g of x is at its minimum. So if you look at g of x here, look what's happening to the y values. Decreasing, 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 minimum, increasing, 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 right? So the minimum is right there, isn't it, right? So that'd be true. The maximum here is greater than 3, right? The function g of x does not have any real x-intercepts. True, right? Because it never gets down to the x-axis, right? It just goes down, but it never touches it, okay? Determine whether each graph represents this function. So it'd have to be the one where the x-intercepts are at -3 and 1, so like both of those would work, right? But A has to be negative, because it has to open down, so it'd have to be that one, right? What about these? So the vertex is at -1, 4, right? And so it'd be that one. And A is negative, so it opens down. Yes, we've done a ton of stuff like this. You can do this. This one is really, I remember looking at this. This one's kind of tricky, but you can get it. If Peter travels 425 miles during the first 6 hours of his trip, then he goes 65 miles per hour. H is the number of hours. Wouldn't you agree that the total distance he travels is just 425 plus 65h, right? If we want to know write a function which describes the average speed during the entire trip, well then you see that it's going to have to be h plus 6, right? Because h is how far he travels at 65 miles an hour, but it took him 6 hours to go 425. That's the tricky part, I think, is that you have to make sure you're dividing by the whole time, right? That's nothing for you guys. That's nothing for you guys. That's nothing for you guys. Okay, these are, we'll just skip through all those. Okay, what about this one? Here's one we could spend just a second on, maybe. So, segment MR is shown, has a length of the square root of 30. Which segment is closest in length to the square root of 15? Now, what I would do here is just pick numbers that you know, right? You're not going to have a calculator on this because they're not going to let you just make a decimal out of those. But pick numbers that you know. Like, what if you had, for example, 2 and 1, the square root of 2 and the square root of 1, right? Think about that. The square root of 2 is roughly what? Square root of 2. It's about 1.4, right? And you could get it, you know that it's going to be bigger. Square root of 2 is going to be bigger than 1, obviously, right? Okay. And so then which one's it going to be? You'd know that it would have to be Q, would have to be the other segment, right?
Yeah, because they're pretty close.
You see what I'm saying?
Yeah.
Yeah, so pick
Kinda
numbers
common sense.
like 30, right, it's just common sense, but it might be easier to pick numbers that you're more familiar with than 30 and 15, right? But the same relationship, okay? Okay, that one's, you can do that, that's no problem. And these are, this is also, don't forget that trick we were talking about yesterday, right? If you want to check it, just like pick a value of x and see which of these are going to give you back the same value of the function when I pick a value of x and evaluate this at x, right? But you know, this is stuff you guys know really well. Yeah. We just were doing this, right before, I mean, you're probably still working on that a little bit, right? Okay, shading the boxes of two numbers whose sum would be irrational. Well, I mean, the sum of the two is going to be irrational if either one of the numbers is irrational, right? So, any square root of 5, now that one's not irrational. The square root of 16 is just 4, right? But that one's irrational and that one's irrational. So, either one of those by themselves with another number or those two together, all those would be fine, right? Rational or irrational. So that's going to be, that's rational because the number can be written as just a fraction. That one has to be written with a square root, so it's irrational, etc. Right? Okay. That one's rational because it's a terminating decimal, right? Okay.
So, like on the last one, on the test, like, can you go back to it real quick?
Sure.
Yeah, so if we got like 3 of them right and 1 of them wrong, does that mean the whole problem's wrong? Or will we still get credit for like a part of the graph?
It varies question to question. I think I wrote a bunch of these. I can't remember. I want to say you have to get them all right, actually. But everybody does, and that's the thing. That's why the scores are so low, right? So, I mean, the scores are not high on this test. It's not like people are getting 100% on this test. You know, it just doesn't happen. Well, I mean, the raw score you don't even see. That's not even. But like when you look at the raw scores that students generate, they're not.
Will we never see
So
them?
when we finish, will we get a score like on the Oaks? Like you submit it.
But
and
we
it's
know
like,
how we did.
I don't know. I don't know. Last year you wouldn't have, but it's changed. Things have
Did
changed
people
quite a
last
bit.
year ever figure out what they got?
Yeah.
Okay.
Yeah. Okay, so all this is, I'm not even going to go through this. This is just one where if we want to convert grams per milliliter into pounds per feet, well then we just have to pick the 3 fractions, 3 changers that we'd have to multiply, right? So we start obviously with that, okay, and then we're going to have to multiply one where we have grams on the bottom and pounds on the top. Then we have to do one where we have milliliters on the top and cubic feet on the bottom, right? So I mean, that's no big deal. But I guarantee you, any order's allowed, doesn't matter. I guarantee you, very few people are going to get that one, even though it's, because you guys are in chemistry, you're going to get it, you know.
Probably not. So, honestly, I'm gonna look at it and be like, that's a lot of work.
Okay, so this is stuff we just went through also. You're going to be fine with that. Oh, we made it through the whole thing. That's pretty good.
Yeah, good luck.
I'm kind of amazed we did that. Okay, so these, you're probably not going to see very many of these, but just go think back to like middle school when you talked about these things, right? So a dot plot, all that's doing is it's saying that means 1 score was 45, that means 2 scores were 50, right? Okay. Okay, you remember boxing whisker
Yes,
plots?
I Googled them. I Googled them when I
You remember how to do those?
No, what's the middle, what's the in the block?
Okay, so
The middle
the
thing is the very
is,
median.
is the median.
Yeah,
The
the
edge of
median is
box
the
is
middle.
median at the bottom
So
half.
I can real quick, here's how you deal with those. You find the median and then remove that point. Then you're going to say, okay, so let's say on this one we have 1, 2, these are in order, good. So 4, 5, 6, 7, 8. So there's 9 of these, right? So 1, 2, 3, that's the middle point. So that's got to be the median, right?
Oh.
See what I'm saying? So that's gonna be the median, and then we're gonna take these ones right here, and we're gonna find the middle value is gonna be,
And then that's the side for the box, right?
right, and so it'd be the average of 13 and 13, which is 13. So we'd have one at 13, right? So the what do we call that?
The whisker or the box?
What do we call that though? The 4-point summary or something like that?
I don't know.
So you get 16, the 5-point summary. 13,
Oh, yeah,
8,
yeah.
right?
And then the middle between those ones, and then 32.
Right, so that would be the average of, because there's 4 of them. If there were 5, it'd be the middle one, but then you gotta average those and get 25, right?
Yeah.
So those are the numbers.
Yes.
Is there gonna be anything with like outlier points? 'Cause, like,
No,
the other night-
I don't think so.
And no matrix for sure.
No
Okay, 'cause
matrix.
I had that on ACT and I had no idea what to do.
Yeah, there won't be any. Well, we did those, didn't we? Yeah, we did.
A
We did.
little bit, a
We
little
did,
bit.
yeah.
And I've done
So,
So-
mode is the recurring number, right?
Mode is the most frequently occurring number, yeah. Median is the middle number when they're arranged in order.
And
Mean is
the
an
average.
average, yeah.
Range.
So histograms, interpreting histograms, remember, this tells us the number of scores, and this tells us the range of scores with that number. So that means there's 1 score between 21 and 24, 2 scores between 24 and 27, right? Etc. Okay, you're good. Yeah, we got through it. That's awesome. I didn't think we were going to. We went through like 60 problems today.
So do we get like the practice date then Monday?
Monday, I want to go. Oh, one more thing. Juniors, come on up here. So juniors, here's the other thing I want you to do this weekend that will really help. If you go to, we'll talk about these on Monday. See, what's great is you guys will do this stuff. My Algebra 2 students want to do this stuff. If you go to SBAC Prep, look at those practice performance tasks. Okay, print those out and look at them, and you're going to be in great shape. We'll go through them on Monday. Yeah.
Thanks, bro.
Thank you.
Okay, that's fine. There are like certain lessons you come down to.
A certain what?
Or like that's what you come down to. With like specified each question.
It'll tell you. Each question will tell you.
Okay.
Yeah. Yeah, just read each question carefully.
Can you? No.